All right, today we're going to jump into the origin story of a database that tried to do something pretty audacious, blend two completely different worlds right from its very first line of code. We're digging into the genesis of YugabyteDB, and it all starts with a real tug-of-war in the world of software. So to really get why YugabyteDB even exists, you got to rewind the clock to 2016. Cloud-native apps were just blowing up, and developers were stuck with this choice that was a massive headache. On one side, you had your classic relational databases, the champs of keeping your data super consistent and handling transactions perfectly. And on the other side, you had NoSQL, built for just insane scale, crazy high throughput, and speed. You pretty much had to pick a side. You couldn't get the best of both worlds. And right in the middle of this dilemma, a new idea starts to bubble up. The goal wasn't to just take an old design and try to bolt on scale as an afterthought. No, this was about creating a database that was born distributed. It was in its DNA from the ground up, from day one. And that new contender? Yep, it was YugabyteDB 1.0. And look, its whole reason for being was a total game changer, because it didn't just add scale, it started with it as a core principle. This wasn't about trying to retrofit an old car with a new engine. This was about building a brand new vehicle for the cloud era. So, the big question is, how'd they pull it off? How do you actually bridge that huge gap between the relational and NoSQL worlds? Well, the answer is in some really fascinating core technology. So let's dig in and unpack what made this thing tick. Okay, at the very heart of this innovation was a super clever idea, a dual API approach. YugabyteDB was basically bilingual. It was designed to speak two completely different and very popular database languages right out of the gate, one for the SQL crowd and one for the NoSQL folks. First up, you had YSQL, and this was a huge deal for anyone coming from a traditional database background. It was a Postgres-compatible API, which meant you could bring all your favorite tools, your existing SQL code, and all that transactional logic you know like the back of your hand, and run it on this new, crazy scalable architecture. Then, for the other half of the puzzle, you had YCQL. This one took its cues from Cassandra, and it was all about one thing: raw speed and massive, massive scale. We're talking about those apps that need insane throughput and super low latency. This was the key to unlocking that pure NoSQL-style performance. But here's the kicker, and this is really important. These two APIs weren't just some layers slopped on top of an old-school database. Nope. Underneath it all was a genuinely distributed foundation. Your data automatically gets sliced and diced, or sharded, across a bunch of different machines. And to make sure everything stays perfectly in sync and your data is safe, it used the Raft consensus protocol. That wasn't an add-on, it was baked right into its DNA. So what did all this fancy tech actually mean for developers? Well, it meant some pretty awesome things. It meant you could just throw more servers at it and your performance would scale up predictably. That's linear scalability, the dream, right? It meant you could have a database that spanned continents but still had rock-solid consistency. And maybe best of all, if a server just died, the system would just handle it, automatically. Rerouting traffic, rebalancing data, no 3 a.m. pagers. Okay, but we all know that cool tech on paper is one thing. The real test is what happens when it hits the real world. And the story of YugabyteDB 1.0's early days is like any V1 product, a story of some amazing wins and, some serious growing pains. So, who were the brave souls who jumped on this first? Well, a few key industries really saw the potential right away. You had gaming companies, who just loved it for handling those wild spikes in player data. Then you had fintech, using it for ledgers that had to be rock-solid consistent, but also needed to scale. And of course, IoT, which needed to just slurp up massive streams of data from millions of devices around the world. And the wins? They were pretty obvious, pretty fast. It proved it could actually handle the crazy scale that gaming and IoT threw at it. It delivered that dead serious, no-compromise consistency that you absolutely need in finance. And it really let companies build apps that were truly global and could survive a whole data center just vanishing. But hey, it wasn't all sunshine and rainbows. I mean, it was a 1.0 product, right? That Postgres compatibility, as amazing as it was, wasn't 100% complete yet. There were some feature gaps. And for teams that were new to distributed systems, let's be honest, getting it up and running could be a bit of a steep learning curve. And the community, while super passionate, was still just getting started. It was small.
But even with those growing pains, you really can't overstate the impact of this first version. It wasn't just another database on the market. It really felt like it was carving out a whole new category and setting the stage for everything that would come next.
When you boil it all down, this is what YugabyteDB 1.0 was really trying to be. It was this incredibly bold vision brought to life. A single database that could talk like PostgreSQL, scale like Cassandra, and was born and bred to survive in the wild, chaotic world of the modern cloud.
So this first release, it laid down a seriously powerful foundation. But it was only the beginning. And that kind of leaves us with a really interesting question, doesn't it? What happens when you take a bold foundation like that and you start to build on it, refine it, and push it to its absolute limits? Well, that's a story for another time.